Hi everyone, and welcome to our video using the operations with vectors and also vectors in terms of I and j. So with our operations in vectors, it's kind of straightforward where we are kind of using distributing or simplifying like terms. So when we do our scenarios here, so in this example it says let u, so here we've got different vectors, so they're using u as a vector and v as a vector. So let u be the vector -2, 5, and let v be the vector -1, -3. Let's find the following and then make a sketch. All right, so to do u plus v, it is just change the u into -2 and 5, and then change the v, so plus v, -1, -3. And then after that, all we have to do is add like components. So the horizontal components will add. Let me go ahead and circle that plus 2. So it is addition in this problem. If that was minus, we would subtract. All right, so it does become negative. Well, let's keep it in blue. -2 plus -1. And then the vertical components, let's do it in purple, vertical components will also add. Okay, so comma 5 plus -3. There we go. That's all we have to do. And then now we'll simplify. So it looks like we have -3 comma 2. There we are. Okay, so that's that number one. Let's sketch it. Now I'm going to sketch it over there to the side. I think we'll have more room. So number one, so sorry, the number one sketch is going right here. What I want to sketch is u. Let's do that in blue. So the u I'm sketching, so that's 2 to the left, and then up 5. 1, 2, 3, 4, 5. I'm going to start that at the initial position and go to that point. There's u. Okay, so there's u. And then from where that one ended is where I'm going to sketch v. So that means I need to go left 1 and then down 3. Okay, so left 1 and then down 3. 1, 2, 3 is about there, I think. Okay, so let me move that u. So sorry, that's in the way. So there was our vector u in blue. Here was our vector v in purple. So this is called head to tail method. Okay, so it's just picking up where the first one left off. And then my sketch isn't great, but if I draw u plus v, that would go to where the purple one ended. And even in the sketch, you can kind of see it. Yes, 3 to the left and up 2 is what's happening. Okay, so there's u plus v in the black. Okay, so that's the geometric visualization of addition with vectors. Okay, so anyway, so I just wanted to sketch that out. Usually we don't really need to in this scenario, but it might be nice. Okay, number 2. Number 2, we have -4v. So that's still just saying, well, change your v into the actual component form of the vector. And then this is where it's kind of like distributing. This -4 will multiply each of those. So this becomes +4, comma, +12. There we are. And one more. Let me make that sketch down below here. Okay, so what I want to sketch is, let's sketch v. Again, I'm just going to sketch that in purple. I'm going to have it start at the origin. So that would be 1 to the left and then down 3. So there's v. -4v, I'm going to sketch that one in the black ink, would be 4 to the right. 1, 2, 3, 4, and then up 12. Okay, so my scale's probably going to get a little off there, but I'm going to say it's about there, like that. Okay, so that is our -4v. So notice it's going in the opposite direction of the original v because of the negative. Again, negatives just make things go the opposite way. And then the 4 is stretching it out 4 times its original length. Okay, so that's all it did. Okay, so that's the visualization of it. Okay, anyway, the other way that we can use vectors, especially with operations, is to use vectors in terms of I and j. All right, so if we have our component form, so there it is with the a1 and a2. So this is component form. We could change it to be in terms of I and j, which makes it look more like an algebraic expression. So all it really is, so let's see this example right below, is just saying get rid of those kind of pointy parentheses and instead attach an I with the first component, so 3. And then they do bold, but just like regular vectors, we'll just put a little arrow on it for us. And then minus, so whatever the sign is, so minus 9 and put a J with it. Okay, so that's it. That's rewriting it. Okay, so and we can go back and forth. So we can use the terms of I and J if we want to, or we can stay in component form. Usually I and J is maybe nicer in the long run. It's also, I think, nice in these operation problems. So for instance, on this one, they give us the vector u. So u is 5i minus 3j, and v is 2i plus 6j. We're going to evaluate 7v minus 4u. Okay, so 7v minus 4u. Okay, so 7, and then v we're subbing in. Okay, careful of the order. They're trying to mess with us. So v is 2i plus 6j, and then minus 4. U is the first vector they gave, 5i minus 3j, like that. And then, so the reason why this is nice is because now it really does look like an algebraic expression where the 7 distributes. The negative 4 would also distribute. So we get 14i plus 7, 14, 21, 42j, and then minus 20i plus 12j. Careful of the negative distributing. It changes the signs. There we are. And then now we'll just combine like terms. So 14i and minus 20i would combine. So that is negative 6i. And then 42j plus 12j would combine. So that's plus 54j. And there's our final answer. And that's in terms of I and j. Again, if we wanted to, we could change it to component form, negative 6, comma 54, with the pointy parentheses. Notice component form has the pointy parentheses. Terms of I and j does not. It is just its own algebraic expression ready to go. Okay, so that's if we wanted it in component form. So if you wanted to convert these to component form, if you want to convert the u and the v into component form, you should get the same answer. Okay, so it'll work out the same way. Okay, so that's how we can deal with the terms of I and j. Okay, for now, let's put a pause. Magnitude coming up. Okay, thanks for watching. I'll see you again soon.